Welcome to lesson 4.3, area of a parallelogram. So the focus of this lesson, we're going to learn how to develop a formula to find out the area of a parallelogram. But before we move on, we're just going to kind of identify what a parallelogram is. So I'm looking at page 139 in our textbook, and I've just taken a little snippet of one of the pictures on that page. If you want to follow along, you can. If not, just look on the screen. So there's four shapes, A, B, C, and D. And my question to you is, which one of these do you think, just using what you know about shapes, which one of these are a parallelogram and why? So essentially I'm asking, what is a parallelogram? So I'll just give you a second to think about it, and then we'll go through what the definition of a parallelogram is, and which of these shapes represent that. So a parallelogram is defined as a quadrilateral. We know that a quadrilateral, quad means four, so it's a four-sided shape where both pairs of opposite sides are parallel lines. And what I mean by that, let me just get my pointer here. So for example, C would be an example of a parallelogram because the opposite sides, so where my pointers, those are opposite sides, and these are opposite sides, and both of those are parallel lines. And we see that the shape has four sides, so it's a quadrilateral where both pairs of opposite sides are parallel. So C would be an example of a quadrilateral. Let's look at B, and we need to see if both pairs of sides are opposite sides. So if I'm looking at the top and the bottom sides, yeah, those two are parallel. Let's look at these ones. So this one goes straight up and down, but I see that this side does not go up and down. So B would not be an example of a parallelogram because both sides do not have parallel lines. If we look at D, D would also be an example of a parallelogram because we look at the opposite sides and we see that both of those opposite sides, those lines are parallel, meaning they'll never touch. And just in case we need just a refresher on what parallel lines mean, it's just lines on the same flat surface that would never intersect. So if these lines were to extend beyond what they are, they would never ever touch or intersect. So D is a parallelogram. And then we look at A, and that A is a pretty familiar shape for most people. A is a rectangle, as we know. But let's think about, does A fit into the definition of a parallelogram? Is it a quadrilateral, or does it have four sides? Yes, we know that rectangles have four sides. And are both opposite sides parallel lines? The top and bottom are definitely parallel lines, and so are the sides. So a rectangle is an example of a parallelogram. That being said, not all parallelograms have to be rectangles. D and C are not rectangles, but A is. So A is an example or kind of a subset of shapes within parallelograms. So looking at these, A, C, and D are parallelograms. So this unit we're focusing on finding the area of a parallelogram. And just to review what area means, in the past in grade 6 you've found the area of rectangles and squares more than likely. The area is just kind of defined as the number of square units that would be needed to cover a region, or essentially by cover we mean like the face. That would cover the face of a shape or of an area. So we're looking at the area of parallelograms today. So we've already kind of gone through what a parallelogram is, and just two things we need to kind of keep in mind, that there's two measurements that you'll find with parallelograms, and we define that as the base measurement, which is the length along the bottom, and it's described on this picture. And then, so that's the length from essentially the two edges at the bottom, or the base. And then the height is the measurement from the base to the top point of the parallelogram. And these two measurements are the ones that we're going to be using when we look at the formula, which we're going to do next to solve for the area of a parallelogram. So I've just put another picture of a parallelogram in here because you might notice some similarities between a parallelogram and a rectangle. And if you recall last year in math, when you were probably doing geometry or shapes, that you learned that the area of a rectangle would have been the length times the width. Whoops, sorry, didn't mean to move that. Would have been the length times the width. And there are very many similarities between these two shapes, although they do look differently. However, what we can notice between a parallelogram and a rectangle, that any parallelogram can be cut essentially and rearranged to make a perfect rectangle. So what this picture is showing, this dotted line, right? If I was to cut that little piece off and cut this triangle off and put it right in here, it would fill up the space and it would make a perfect rectangle. So that really helps us when we're starting to develop a formula for a parallelogram, because we know that the shape of a parallelogram is actually the exact same shape as a rectangle, it's just rearranged in a different form. And what that means is that the area of a parallelogram will be exactly the same for the same size rectangle. That being said, when it's time now to develop the formula for a rectangle, if we know that finding the area for a rectangle is length times width, again, the names of those are a little bit different for a parallelogram. We have base times height, but we know that it's the same thing. We're going to multiply one side by the other side to get the whole area. So the area, so the formula that you'll need to know to find out the area, the area of a parallelogram is base times height. And it's as easy as that. Or you might see it in your book represented like this, but we know that's the same thing. So let's do one example together before you go off and you do the practice questions for this unit. So again, on page 141 in our textbook, I've just taken a little snapshot of a parallelogram that's on that page. And I'm asking you to figure out the area for this parallelogram. So this parallelogram is kind of flipped on its side, but we still have the two same measurements. We have our base measurement and we have our height measurement. So we know that our formula is area for a parallelogram equals base multiplied by your height. So like we've always done in the past and we keep practicing, we just need to plug the numbers into this equation where they belong. So, do I have the area? No, I'm trying to figure that out. Do I have my base number? Yes, I do have my base number, which is 7, so I'm just going to plug that right where the B would be. And do I have my height number? Yes, I do. I know that my height of my parallelogram is 5. So I'm going to plug that in where the H would be. So the area of a parallelogram is 7 times 5, or base times height. So our area is 35. But remember, because we're looking at kind of the square units it would need to cover the surface of an area, our answer would be 35 centimeters, because we're never going to forget our units. And we always need the squared to represent an area of space. So our answer for this is 35 centimeters squared. Just a few reminders for this unit. You will need graph paper. You're going to be asked to draw some parallelograms. And with your graph paper, each box represents 1 centimeter by 1 centimeter. So just come to class prepared with that. And if you have any questions, let me know. Thanks for listening.